Okay, let's talk about a piece of everyday magic. GPS. Seriously, think about it. It gets you to that new restaurant, it tracks your morning run, it tells you exactly to the minute when your pizza is going to show up. But have you ever stopped to wonder how it actually works? I mean, what's really going on behind that little blue dot on your screen? To really get how important this is, let's do a quick thought experiment. What if you woke up tomorrow and the entire GPS network was just gone, switched off? It wouldn't just be inconvenient, forcing you to use a paper map. No, it would be a full-on global catastrophe. For one thing, global trade would just stop. Those massive container ships that carry like 90% of everything we buy, they completely rely on GPS to navigate the oceans. Without it, they'd be floating blind. Our entire supply chain would just completely fall apart. And flying? Forget about it. Air travel would become way too dangerous. Modern air traffic control is basically a giant GPS puzzle, managing thousands of planes in the sky at once with pinpoint precision. You take that away, and you have to ground almost every commercial flight on the planet. But here's the one that might really surprise you. The world's financial markets would freeze. Why on earth would that happen? Well, it turns out GPS isn't just about where you are, it's about when you are. The system provides the super accurate timestamps needed for every single high-speed stock trade. No GPS means no synchronized time, and the whole system just grinds to a halt. So yeah, it's pretty clear our entire modern world is built on this invisible system. So to really appreciate it, we've got to pull back the curtain and see how the trick is done. And it all boils down to three main things: satellites, the signals they send, and, well, you. Officially, it's called the Global Positioning System, or GPS. We're talking about a constellation of about 30 satellites, all zipping around the Earth at something like 7,000 miles an hour. And the whole thing is managed by the U.S. Space Force. All right, here is the absolute most important thing to understand right off the bat. Most people think that those satellites are up there in space, tracking you, watching your every move. That's not how it works at all. In reality, the satellites are basically just dumb lighthouses. They're just broadcasting a simple one-way signal. They have no idea who you are or that you even exist. Your phone is the real hero here. It's the smart device that's listening for those signals and doing all the calculations. So the whole system really has just three simple parts. First, you've got the satellites. Think of them as cosmic clocks, constantly shouting out two things over and over. Here's my exact location, and here is the exact time. Second, you have ground stations back here on Earth. Their job is to keep a close eye on the satellites to make sure that the information they're shouting is absolutely perfect. And then third, there's the receiver. That's your phone or your car or your watch, and its job is just to listen. So, how does your phone take those simple signals and turn them into that dot on a map? It uses a really clever mathematical trick called trilateration. Now, I know, that sounds super complicated, but the basic idea behind it is actually surprisingly simple. Let's just imagine it in 2D for a second. Let's say you're lost somewhere in the US. You ask someone and they tell you, well, you're 400 miles from Boise, Idaho. Okay, that puts you somewhere on this giant circle. Then you ask someone else and they say you're 780 miles from Fargo, North Dakota. Now you've got two circles that cross in two places. We're getting closer. Finally, a third person tells you you're 410 miles from Salt Lake City, Utah. And bingo, there is only one place on Earth where all three of those circles intersect. You're in Bozeman, Montana. GPS does the exact same thing, but it's in 3D, using spheres instead of circles. A signal from one satellite tells your phone it's somewhere on a massive imaginary sphere. A second satellite creates another sphere, and where they intersect forms a perfect circle. A third satellite signal narrows that circle down to just two possible points. And this is why a fourth satellite is so important. That fourth signal confirms which of the 2 points is actually you. It calculates your altitude, and this is key. It corrects for any tiny, tiny errors in your phone's own clock. So your phone is basically solving a super complex 3D geometry problem over and over every single second. Okay, now we get to the really wild part of this whole story, the part that sounds like it's straight out of science fiction. Because for any of this to work, the timing has to be absolutely perfect. And to get that perfect timing, the engineers who built GPS had to deal with one of the most famous and mind-bending theories in all of science. So remember, your phone figures out how far it is from a satellite by measuring how long the signal took to get to it. And since these signals travel at the speed of light, even a minuscule error in timing can throw your location off by miles. That's why every single GPS satellite has multiple atomic clocks on board, clocks that are accurate to within a few nanoseconds. That's billions of a second. So you just need perfect clocks, right? Simple. Well, not quite. Because what if time itself isn't a constant? What if I told you that for the satellites up in orbit, time is literally moving at a different speed than it is for us down here on the ground? And this is where Albert Einstein enters the picture. His theory of relativity proved that two big things affect how fast time passes: how strong gravity is and how fast you're moving. And because the satellites are in a weaker gravitational field, and they're also moving incredibly fast, their clocks actually run just a tiny bit faster than ours do down here on Earth. So how much faster are we talking about? The number itself is just absurdly small. Every single day, the clocks on those satellites get ahead of the clocks on the ground by only 38 microseconds. That's 38 times millions of a second. It seems like absolutely nothing, right? An error so small you could just ignore it. Wrong. So wrong. If the engineers didn't constantly correct for that tiny 38 microsecond difference, the errors would build up so fast that the entire GPS system would be off by about 6 miles every single day. Within just a few hours, it would be totally useless for navigation. So yeah, think about that. Without Einstein's century-old theory of relativity, your Google Maps just wouldn't work. So when you put it all together, the satellites, the math, the mind-bending physics, you get this incredible system that has become the invisible backbone of our world in ways that go so much further than just a little dot on a map. You know, the whole idea got started way back in 1957 when scientists figured out they could track the Russian Sputnik satellite from the ground and thought, hey, maybe we could do that in reverse. The first experimental satellite went up in 1978, and the system was fully operational for the U.S. military by 1993. But the real game changer was in the year 2000, when the government decided to make the most accurate version of the signal available to everybody for free. And that one decision just unleashed this explosion of innovation. We already talked about banking, but it's also used for precision farming to guide tractors with incredible accuracy. It helps emergency services find people who need help. It's used by scientists to track the tiny movements of continents to study earthquakes. It even synchronizes the cell phone networks that connect our calls and run the internet. And while the American GPS is the one we all know, it's not the only show in town anymore. Other major countries and regions have built their own systems. Russia has GLONASS, Europe has Galileo, and China has its own system called Beidou. In fact, the smartphone in your pocket right now is probably listening to signals from several of these different systems at the same time to get an even more accurate lock on your position. Which really brings us right back to where we started. From how we move, to how we buy things, to how we farm our food, we have quietly built our entire civilization on a faint, invisible signal sent from 12,500 miles above our heads. It's an absolutely incredible achievement. But it does leave us with a pretty big question to think about. What happens if we become too dependent on this magic trick we can no longer live without?